Now in this video we will see why we are using GAN for the image super resolution. This is the video we will only see the brief about why we are using GANs for the image super resolution, but we will go more depth in the GAN in the next following video. We will see how the GAN is going to be work, how inside the GAN there are two type of models we are going to work. So we will see this thing in the details. But here I am just using only one type of techniques that we call as a GAN. We call it why we are using GAN for the image super resolution. So basically we have a generative adversarial neural network. Okay, so basically what we do, we are just taking an input as a low resolution images, what we have just talked in the previous video, and that with the help of any image super resolution model we are just getting high resolution images. But the main thing is that not only getting high resolution images, we have to just more consider that images will be more photorealistic, that images will be realistic images, that should be not even any artifacts has been added to the high resolution images, or that images should has high texture detail, which detail has been lost in the low resolution images. That lost detail or the texture detail will ever to gather, or we can just say generate on the high resolution images. This too is the most important thing whenever we are just going to go with the high resolution images, or whenever the model is going to generate a high resolution images. That is really the plus point, because in the GAN network that was really giving a really a good accuracy, not on the terms of how the humans is, how any person is saying. We are going to say that you are just using some model and you are going to say that whether this particular picture or the images is going to be look like photorealistic, or it's like some artifacts has been added. That is basically we call as a human perception. We are going to see this thing in the much detail. There are various type of that is a matrices. The one we call as a subjective and another we call as a objective. Subjective is basically how human person is going to see, and then after he want to just give a scale out of 5 how your image is going to be look. Then the other model, that is a human, we call as a subjective. And there is also objective like PSNR, SSIM. We will talk this thing in the future slides. So the main thing is that why we are using GAN for the image super resolution. The plus point is that the GAN network is able to generate a high resolution images, that particular specific photo is a realistic, and also it is able to just generate a high texture details. Even the detail you have just lost in the low resolution images, that detail is going to be covered at the high resolution images by using the GAN technology. And also there is no such artifacts has been added to the images. It's not like you're getting 100% a photo realistic images, but you are just trying to take that photo, the look that photos, that should be a realistic images. That is really the plus point we are going to see. So basically in the GAN we will talk, there are two type of neural network. Basically we are the one we call as a generator, another we call as a discriminator. Okay, so the one is a generator, another is a discriminator. Why we call as a generator, another is a discriminator, we will see again in the more details. The generator is basically which generate a high resolution images. We are just training a generator. The main is the only the generator. How we are just training inside the GAN, we have two type of network. The one we call as a generator, another we call as a discriminator. Generator is basically we are just taking a low resolution image and we are just generating a high resolution images. But while in the discriminator we are just taking the high resolution images, that is the real images. We already have the real images, we did not use in the anywhere in the generator. But what high resolution image that has been generated by the generator, now we are going to compare, and we will give input to the discriminator. The real images, that is already the ground truth we can just say, and the images, high resolution images that has been generated by the generator. This two we are going to give to the that we call as a discriminator. And discriminator model will try to say which is going to be real images and which is going to be look like a false images. This thing again we will go in much detail about the discriminator loss, generator and generator loss. So here I am just giving the overview of everything. And the basically the GAN are promising basically approach for the image super resolution, as they can generate a high resolution images and they are more realistic and high quality compared to the purpose of other method we are going to see. So that is the one promise the GAN is going to give you, that we whenever we are just generating a high resolution images, we are not only giving you high resolution images but images as is more realistic. There is no such artifacts has been added to the images, and also the quality of the images is really high as compared to the other deep learning models. So that's why we are using the GAN, and we will see how we are just implementing the GAN and what is really important in the GAN. So that's all. We'll see in the next video.